this? Can I cover this up real quick? Is that all right? All right, I got some height data here. Let me fire it up. Oh, you can't see that, can you? Nope, you can't. Hang on. Spread heights. All right, I want to collect some data real quick. Here we go. So, let's do this. I want to keep track of our heights in this class and see, this was last term's class. Blue is the female in the early class, red is the male in the early class, and green is both. I want to collect your guys' data, so I'm going to go through the heights to the nearest inch. Raise your hand if you're that height to the nearest inch. Now, I want to see. I'm not convinced that we have enough data to see a bell shape, but I'm curious to test the hypothesis that people are bell-shaped. 4, 6.
Are you rounding up or down?
Say that again?
Are you rounding up or down?
To the nearest inch.
So, well, I'm 5'11 and a half. So
Then I would go up to 5'12 or 6 foot, right?
6 foot.
Go by standard rounding rules. I am too, 5'11 and a half. It always pissed me off because I'm never quite 6 feet.
Exactly.
Go by standard rounding rules, right? So, oh, that's a good point though. Any half will round up because we don't have that kind of precision. What the hell? Round up, that's fine. 4, 6, 4, 7, 4, 8, 4, 9, 4, 10. That is tiny, isn't it? 4, 11, 5, 4, 12, 5, 0, 5. We got 5. There we go. Boom. 5, 1, 5, 2, 5, 3, 5, 4. Okay, so we got 5, 5, 5, 6, 5, 7, 5, 8, 5, 9, 5, 10,
0 and
5, 11. We only have at least 1 6, 2 6s, 3 6s, 4 6s, 5 6s. 6 1, 6 1 and a half?
Yeah.
That means we're going to put you at 6'2" then, right, Dre? 6 1 and a half, yes?
Yeah.
How about 6 1? We got 6 1, we got a 6 1. And you're 6 1 and a half, we're going to call you 6'2". Anybody else 6'2"? We got 3 6'2"s. How about 6'3"? Anybody above 6'3", 6'4"? What are you guys? 6'4"? JT 6'3", so we got a 6'3", we got a 6'4". Anybody above that? All right, there's our data. It's looking a little bell-shaped. I like that in there, yes? I like that in there. That blue is looking bell-shaped, and so is that red. Now, what's interesting is, it's kind of hard. It definitely got holes in it, right, Eric? Eric's like, that doesn't look bell-shaped to me. It's got holes in it. We also have extraordinarily small, especially with the guys, extraordinarily small data sets with the guys. I mean, how many guys do we have in this? 1, 2, 3, 4, 5, 6, 7, 11, 12, 13, 14, 15, 16, 17. I mean, less than 20 guys represented. The fact that the bell shape is showing up at all is kind of interesting to me. Now, what I did on the back in the green chart was to show you both data sets put together. Because this is sometimes, very often, what is ignored. They can take something like heights or wages earned or something like that and graph guys and girls together, and that looks bimodal. That's the green graph, yes? Well, that's because you've got two populations maybe that differ significantly. It appears as though on average the female heights are less than the male heights, yes? If you had to attribute a height to the females, average height, what would you call it, friends? 5'3", 5'4", somewhere in here? I think it's looking around there, maybe 5'3 and a half, somewhere in that neighborhood. How about the guys?
6 foot.
Maybe 6 foot in this class, yes? Now here's a fun one. If you had to approximate the standard deviation without grabbing your machines and running numbers in, could you do it off of just the graph? For example, let's pull the guys out of here and the totals out of here. Okay, there's the girls, right? If you had to approximate the standard deviation of those heights, could you do it with a real quick estimate? Based on what we just, would you call that roughly a bell shape, first of all? First of all, convince yourself you call it roughly a bell shape. Are we okay calling it roughly a bell shape? We're okay. Could you use what we just learned right there and say, okay, I can maybe figure out roughly what the standard deviation is based on those rules? Absolutely. Tell me how you do it. Tell me how you do it.
Balance the thing.
Find the balance, right? Where'd you guys say the balance was again?
Right about there.
Right about here, 5, 4. So there's your balance. There's X bar. Okay, good. Now what?
I say
Go out. How far? How far?
2 inches.
Maybe you collect all. It's a very small data set, yes? Maybe collect all of it, yes, like this? How many standard deviations do you think that is? What do you think? I would call that roughly 2. We've got such a small data set, we're not going to see crazy outliers, most likely. That's probably 2 standard deviations ballpark, yes? So if that's 2 standard deviations, 5,0 up to 5,9, that's 9 inches in total, correct? That's 9 inches in total, which is very nicely sits with what you guys call the average, right about 5'4½", somewhere about there. So if the average is in the middle of that 9 inches, what is S, the sample standard deviation? 4.5 would be 2 S's, correct? Up 2 and down 2. So if 4.5 is 2, 1 would be about 2.25 inches. So if you know the data is bell-shaped, you can get a real quick ballpark working guesstimate of what S actually is. By just simply doing, okay, 2 standard deviations, roughly most of the data besides the outliers, and then take that range, cut it in 4, that's roughly what S is going to be. This is really handy when you don't have a machine handy to actually run the data through, or you don't have the ability to run the data through. Does it work for the guys? Let's find out. Undo, undo. Let's get rid of the girls. Now Excel, unfortunately, doesn't have a quick command that I can use to do this with. So what should we do with the guys? Where's the average, first of all, friends? Right about here? 18.5? Oh crap, I lost my range. What the hell? Hang on, let me get it back. Why did I lose my range? That's very strange, huh? Don't worry, I can fix it, I think. I'll just do my select data. Thank you, Excel, for once again being such a pain in my ass. There we go. All right, so you said it was right about here?
Yeah.
That was slick, actually. You guys weren't looking at the numbers and you still had an idea. You were saying it was about 6 feet before, and that's pretty much where it is, yes? 5'11½". So, there's average. Where should 2 standard deviations go, friends? You tell me where to stop. Maybe like here? And then leave this, maybe call that an outlier? Okay, so we went from 5'7" to 6'4", which is how far? Is that 7 inches? No, that's 9 inches again! That's 9 inches again. Why am I so excited? Because study after study after study after study shows guys and girls have essentially the same standard deviation, although their averages are different by about, say, 6 or 7 inches. So you guys demonstrated very nice empirically that you guys have the same standard deviations-ish between the girls and the guys with our little ballpark there. About 2.25 inches, right? Pretty slick. Pretty slick. Make sense? Ballpark? I haven't finished this Excel sheet yet. I want to actually have it calculate to the nearest tenths the standard deviations. I'll have it updated for you guys on Thursday. Let me save this data though. Undo. There, let's save that. Save your new data. And I'm also going to update it with my historical data that I've got so far. I'm going to put all your data together and see how it all plays out. We can track trends. See if COCC students are getting smaller or bigger over the years. Changes in nutrition. I'll probably be here till I'm 85 anyway. Good. All right, fantastic. So, questions you got right now for me? Got a pretty good working feel about what the hell's going on with 2 standard deviations, 1 standard deviation, bell-shaped data. I don't want to leave bell-shaped data behind right now. I don't want to leave bell-shaped data behind. I want to keep talking about it, but I want